I don't know, we actually had to stop writing our paper because we could go on forever. And so this guy started screaming at me. And I'm like, no, because we can say this. And I'm like, no, okay. So eventually he jerked it out of me.
By the way, this is really a D+1 tuple.
Yes, yeah.
For each of your group, that will be a different D+1.
Well,
A different D.
oh
Yes.
yeah, absolutely.
Yeah, because the dimension of the special
The
representation.
function,
Yes,
not the
correct.
number of variables in your
Yes,
function
yes,
is this.
Yeah.
are different.
So this is it, and this is a very wonderful invariant, and you will see its products very soon. Okay, and of course I explained to you what that is, and I don't have to go through this. Okay, so for example, consider the exceptional non-orientable surface group G. Now I call it exceptional because it is not fully residually free. It's not even residually free. It happens to be a linear group. Okay. Now, using a result of mine from 1995, one can show that the spatial representation of this group is equal to C. 6. I'm sorry. And by a bunch of Russian, Benyash, Krivets, Chernosov, 1997, we can deduce that the number of 6-dimensional components of this algebraic variety is equal to 1. Therefore, we have that is going to be a profile function. Okay. So now we get into comparing profile functions.
Oh, you spelled it right. Good.
Yes, I did. I'm sorry.
No, that's good now.
Okay. I mean, I'm not being consistent. So now we are getting into comparing profile functions, okay? And so I'm going to set a theorem of algebraics on myself that allows us to actually take excursions into, surface groups, orientable and non-orientable ones, but I will only deal with orientable surface groups. Okay, so let W be a non-trivial, freely reduced word in the commutator subgroup of Fn equals to this, the free group rank n, and let G be this, okay? And consider the spatial representation of G over something complex. And suppose that this is an irreducible algebraic variety, okay? This is the easy statement of this theorem. I mean, we actually did it in terms of other terminology, but I wanted to actually make it more palatable, dress it up a little bit into public, more acceptable terminology. So here we are. So, and suppose that this algebraic variety, this of -1, is equal to this. So this is equal to rho, homomorphism rho from the space of representation of the free group with the property that this word here is sent to -1. And suppose that this algebraic variety is not empty. Suppose that this algebraic variety is not empty, then the profile function of G over SL2 complex is equal to the profile function of G of a PSL2 complex. Now, PSL2 complex is a SL2 complex when you kill, you kill the center. Okay?
Also minus the identity.
Yeah. So now, a consequence of this immediately is, let G be a fundamental group of a compact orientable surface of genus G greater or equal to 1, then P sub D of R, the space of the profile function of G over SL2 complex does not equal to the profile function of G over PSL2 complex, where D is equal to the dimension of R sub A of G. Now, let me actually show you why that works. Now, the relator W of an orientable surface group lies in the commutator subgroup of the free group on 2G generators, right? We know that. Where G is equal to the genus. Now, Rapinchu, Benyash, Krivets, Chernosov, we know by some other work that this is an irreducible algebraic variety. Okay, so the condition, one of the conditions is actually met. Orientable surface groups, yes. But we actually prove for non-orientable surface groups, but I don't want to burden you with all this stuff because there's too much. So we actually are just focusing on orientable surface groups at this time. So now the result follows once we show that V sub -1 is not empty. Okay, so we actually have to look at this algebraic variety now, and actually, thanks. I remember that you sent me the two matrices.
Yeah.
Okay, now, yes, by some treacherous calculations that this man did, he came up with matrices in SL2 complex. They're not treacherous. That's just a joke.
There's a big family of them.
There's a big family of them. In fact, so you can find matrices with a property in SL2 complex such that this is equal to
That's the commutator. Of
Yeah,
the
negative the
matrices.
identity. That's a commutator, right? So there are such things. So right away, okay. So we can evaluate this to equal -1 simply by mapping each of the generators in these relations here, okay, to I, and sending these two generators to two matrices, you know, that have commutator equal to -1. So right away you're going to get, you know, the whole commutator equals to -1. So then you know right away that that algebraic right is non-empty. So but right away the theorem that I cited initially of, you know, Majovic and myself kicks in, and you can conclude then that, you know, the profile function for an orientable surface group over SL2 complex is different from the profile function for an orientable surface group. Did I say SL2 or PSL2?
No,
You know, when you change the affine groups, it changes, okay?
Yeah, I'm sorry. So
Go ahead.
our idea was to study this profile function to see how it varied from an algebraic group to some quotient. So the natural one was to look at SL2C and PSL2C. PSL2 is just SL2C modulo plus or minus the identity.
Right.
Of course, the next question would be what happens when you mod out by a different normal sum?
Oh yes, but the thing is that we could
Things
actually
get
do
very
that. But
hectic.
you could do that. We could do that. But do you really find that interesting? I mean, I think that's other people could actually work.
Yeah, I don't want to go back to those things.
It was a horrible.
Says the tour is over.
You know, we introduced the mentality. Someone else can do that. Okay.
Yeah, let someone
You know,
else do
it's
it.
like, okay, someone else can do that. I'm more interested in pursuing other
Different
things.
invariants. Right?
Yeah. So, okay. So torus knots again. Okay, torus knots again. Okay. A torus knot has a presentation of the type like this. Okay, where P and T are relatively prime positive integers, right? So, theorem, Liriano Majovic, 2008. Let's well,
Why don't you just call
so
me
let
Joe?
G have presentation as follows, where P and T are greater or equal to 3, are relatively prime integers. Then the number, okay, of 4-dimensional components. Remember that for SL2 complex we said that they were the same? The number of 4-dimensional components is not equal to the genus of the torus knot. So right away, when you kill the center of SL2 complex, you end up with this situation. This no longer. So I mean, I am actually taking you through an orgy of examples showing you, you know, like how sensitive this stuff is. You know, the invariants of algebraic varieties are really sensitive, and they really should be studied. You know, and so right away that result, you know, that I cited earlier, where the genus was equal to number 4-dimensional irreducible components, just collapses. So now this is no longer the case when you move into PSL2 complex, when you kill plus or minus the identity.
Yeah.
Which is a very, you know, it's a very, I know it's bad, but you know what, I like it because it shows that there's a lot of sensitivity here. So in essence, this is also a positive thing for Parafree groups because it's, you know, it says, well, look, you know, you're poking Parafree groups to something very deep. So, you know, the fact that they are not similar algebraic geometrically to free groups is not something terrible. You're only measuring the sensitivity of the machine, you know, whatever you're working with. Okay, so, and of course, a corollary of this, as you would imagine, because the number of 4-dimensional components is different, is that the profile function of a group G, there's a torus knot group, changes from the profile function of the group G over SL2 complex and PSL2 complex. Okay? So that's immediately something that happens. Now, algebraic geometry is not your savior. Please do not jump into this. You know, do not do this. You know, do not do this. Given the positive tone of what we have been talking about, it is prudent that I really trash it because, you know, it is important to trash things a little bit. You know? That's part of, you know, that's part of becoming enlightened. It's trashing yourself, right? Okay, good. So I'm going to trash it a little bit. Okay. So here it is. I call this the sobering lemma. Okay. You remember the sobering?
Yeah.
Given any algebraic group A, there are continuously many non-isomorphic finitely generated groups with isomorphic representative varieties over A. That means that you have continuously many, groups, sharing all the same invariants. Okay? So, this is not so great. This is just accountable stuff. Okay? This is not God. Okay? Assuming I don't know what that means, but anyway. So this is just a very ordinary stuff in some sense. But please do not be so negative. There are only countably many, hyperbolic groups. There are only countably many automatic groups, and people are spending all their time studying them. So be okay, just calm down. Okay? So this is not so bad. The sobering lemma is not so bad. Anyway, that was the end of my talk. That's it.
Very nice.
Are there any questions?
There are several prerequisites to this whole deal, but it's very interesting stuff. And
It's nice.
Sal's work, he has a few papers already out there on the internet. They're really good, and it's worth looking into. And
Well, they should look at your paper.
and my name ends in a Z.